Hi, I'm Jacek, and I'm here to talk with you about a test driver. Actually, we do that today like twice. This is the short talk. My goal here is to um, tell you things about a test driver that you might not have heard about it. It's a really powerful tool. Also give some oversight on what's new there, what's the architecture, where to look if you would like to study it because you feel intrigued and stuff like that. No demos, but today at 3:30 we do the workshop, and that will be all about demos. So this is like very theoretical and later very practical. If you find anything here interesting, please also join the session later. Okay, one word about me. I'm the founder of the Nix Academy. Operates under the Applicative Systems Group label here in the US and in the European Union. We've been training more than 600 people in the last 2-3 years in Nix and NixOS, so really help organizations ramp up on Nix. Very often, I know from my own experience, that takes years. If you want to take it months and have everyone the feeling like, again, like why Nix is important for them too, not only for the org, we can fix that. There's a price tag to make it in months. And we have several organizations where we trained all the engineers and they really ramped up on speed. So that's a huge ROI that you get there. So if you find ramping up your org difficult with Nix, contact us. We can help you fix that, like with all the other orgs. There's also the Nix anti-patterns book. It's pretty new. This is the last chance to get it for free. Outside on the table, please pick your copy. We used that as a little test balloon, got surprising, like overwhelmingly great feedback, so I decided to sell it now. But I think there's like 30 copies still left over. Get yours. Okay, about the test driver. So the NixOS test driver, who has already heard about it so far? Please. Okay, who has used it so far? Okay, a few. So the test driver is a Python app, essentially. And the problem that it tries to solve is to provide you a very simple way to say, okay, let's spin up 5 VMs with certain configuration. One might be an email server, one is a web server, and then you do certain things where you simulate a client to do whatever you like. The NixOS project also uses it to test their own installer, to test Kubernetes, to test MySQL, sharding, whatnot. Everything that can be tested by providing a little environment with multiple VMs that try to simulate some kind of real-life scenario can be modeled with this test driver. So if you need complex test scenarios that run quick, this is for you. In general, we basically have the driver. You are operating from the driver perspective, and then there's multiple Python objects like machine 1, machine 2 that you can access and start, stop. You can power cycle the machines. You can communicate with them via serial. You can log in via SSH when you want to debug. So there's different modes. One is the quick sandbox runs. One is the interactive mode. I will show it to you. You can even run graphical VMs and test graphical applications. You can make screenshots and stuff like that. So the test driver gives you access to all these things. And you can also run machines in multiple networks. So there's blue and red networks on this picture, which kind of shows that you can have multiple VMs running in different networks to, for example, test networking, routing, and whatnot. This is my favorite example of an integration test. It tests a BitTorrent service. So the BitTorrent service is basically peer-to-peer file exchange, right? And to test BitTorrent, what they did in the NixOS project, because transmission is the torrent client that's packaged in Nix packages, and there's also a module that you can activate. They set up a tracker where they have a transmission client that kind of seeds a file, and then they have Apache serving the torrent link and OpenTracker coordinating all the file shares. And then they set up a client that is in this red network. So that simulates a home network subnet, and the blue network simulates like the internet. And this client is behind the router, and then they would kind of transfer the file, and then they switch off the transmission client and the tracker and switch on the transmission client and client number 2, so that the file needs to move from here to there now, which is behind the firewall. So they also test how transmission unlocks the port here via mini UPnPD and so on. You can imagine that we're not only testing BitTorrent here, we're testing NixOS network configuration, we're testing Apache, we're testing OpenTracker, we're testing net routing settings, we're testing UPnPD and stuff like that. And that is a pretty complex scenario here, actually. And you can imagine that NixOS can actually reach this high packages per maintainer ratio and keep them up to date and running, because there's so many tests that track this stuff, and it gets very apparent when something breaks with a little update. However, the infrastructure that we define here is defined in roughly 50 lines of code. You just need to write 50 lines of code, asterisk, I'm removing all the bracket line noise kind of, but the actual code is like 50 lines that describes all this infrastructure. It's just a few NixOS configurations shoved together, and that just works. There's another 60 lines of Python that does the test script, like create the file, share it, blah, blah, blah. And the whole test runs in below 2 minutes on your laptop now. So this is kind of the simplicity and power of this framework at the same time. There's also graphical tests that you can do. My favorite one is the Google Chrome test in the upper left. So Google Chrome is one of the first browsers that puts tabs into each processes and isolates them from each other. And they are calling that sandboxing. And the thing is to test if your Chrome is properly configured at build time and running with sandboxing enabled. That means that you have to run Chrome graphically. There's no command line flag that gives you that. And you go to Chrome://sandbox, and there the page says you are adequately sandboxed. What this test does, it runs a graphical VM, runs Chrome, clicks into the middle of the window, runs copy, pastes it into a buffer, and then grabs out of this buffer if you are adequately sandboxed, yes or no. And the test is parameterized on different binaries of Chrome. It's really small, and it runs also below 2 minutes, I think. They also test multiplayer games for the client-server connectivity. They also test GNOME, and there's kind of text recognition too. You can make screenshots of a running VM, and you can also check if there's certain text graphically on that thing, which is really amazing. Sometimes I put QR codes on these slides, so we have on the nixacademy.com blog examples of this that go more into detail. What is also really interesting is that sometimes people say like, okay, yeah, Vagrant also enables me to build multiple VMs, but I wouldn't build a test with that because that means 5 VMs means 5 VM images that takes ages to build. And then imagine the build infrastructure. If 100 developers do that all the time, you have like thousands of images clogging the disk. What is apparently interesting, and I'll show you that in detail later in the workshop session, we're not building any images. With the BitTorrent test that you've seen earlier, we would build the so-called top-level derivations. So that is a set of store paths that get thrown into your host's Nix store while building that stuff. When we launch those QEMU VM sessions or processes, we just map the host's Nix store read-only into the VM, and it selectively boots those paths to get its configuration there. So you change the configuration from a BitTorrent test here and there, change some host name, whatever, and rebuild, and you're running in seconds again. There's no images. So this is really quick, really fast. It's really different than other tool sets. This is how a test looks like. I have a manual one here. So when I said earlier that BitTorrent just needs 50 lines of code, I was referring to the blue part here. That's the list of nodes. What's interesting here is we're saying machine 1 exists and machine 2 exists, and you're abbreviated, you just add a lot of config that can be random NixOS config. And then what the test driver does later in the test script, which is the imperative part, so that is declaratively describing your existing infrastructure without running yet. And then when it runs, you can start the machine, stop the machine, do whatever you like. Here, because we named them machine 1 and machine 2, we get a machine 1 and machine 2 Python variable. And here, this is real Python. I exaggerated it a bit with the for loop, but it's to demonstrate that we're using real Python here. You can also import your own packages and so on and so on. And not only get Python variable names here, you also get DNS names. So one machine can ping each other using those names as you describe them up here. So there's a lot of default settings that are taken off your shoulders to quickly get something running like this. As you can see, this is just an attribute set with an attribute name, nodes, and test script. That isn't in derivation yet. You typically run it through packages.testers.run NixOS test. And that creates the derivation that puts the Python app with your VM configurations and everything together, and then can run them in the sandbox that then produces your test fail or not fail result. So that typically happens in one big step. And that's as simple as that. The test then run in the sandbox, right? So the Nix builder typically builds whatever you like. PDF files, package compilations, repackages Python stuff or whatever, or it just runs 20 VMs in the sandbox. It doesn't care, which is pretty cool because this way tests don't only become very reproducible. It's also that your build infrastructure becomes your test infrastructure. So in many companies, build and test infrastructure is something different and separate from each other, and test infrastructure is really complex. But when you use Nix and accordingly design your infrastructure, you just have a huge set of builders that build and test and do that very quickly. What's also cool is because the builders just run the same thing in the sandbox as you do. If your CI goes red because some complex test failed, you would just reproduce it on your laptop and then fix it, and the first commit that you push already contains the fix that made it work. So there's no more the CI is the single source of truth, and I'm committing and pushing and hoping, and oh, it still didn't fix it, so commit and push again and again and again, or press the replay button. You're liberated from that. Everything that runs on your laptop will also run on the CI. This is the interactive mode, so if something fails, you can check out the test, and let's imagine you have a test that runs for 1 hour, and then you fix something. Although it runs locally, you don't want a feedback loop that goes for 1 hour or 2, whatever. The interactive mode allows you to run a test the same way as it will run in a sandbox outside the sandbox, and then the VM windows pop up in front of you, and you can log into them individually. You can SSH into them, you can play around. So if something fails, you can look at the logs, you can install more debugging tools, you can really dig deep what the test problem was, fix it, and then run it in the sandbox again, finally commit and push it, and it's gone, it's done. So this is pretty cool because the interactive mode also has this nice text completion, so you can find out what is there, how do the procedures work, and then find out how to even test your software. So while you are playing around, you can take your notes and actually set everything in stone for the actual test later. So this is really useful and really easy to use. Integration tests also run on macOS, because macOS can, of course, run QEMU natively and then run your VMs inside there. So that is supported. Nix packages itself contains more than thousands of these tests. It's like last time I've seen with counting the lines in the NixOS/tests folder, it was 1,100. So there's nothing that hasn't been ever tested. So if you kind of are like, how would I do that? You could look into this folder and check out other tests and get inspired from that. There's wild scenarios that are elegantly implemented that you can kind of use for yourself. The architecture looks like this. Sorry, I think the text is a bit too small. So in general, you have like 2 profiles, the QEMU VM profiles, which also work without the test driver. So you can quickly import the QEMU VM profile in NixOS config and then spin up a VM in front of you and play with that. The test driver just makes it so that you can orchestrate multiple of those and put them into a network, which is of course a little bit more complex. What's new is there's also a systemd-nspawn container profile that also works alone, and we can now use both. I will talk more about containers in 1 minute. The test driver is just put on top of that. The test driver is basically a Python script that's bundled with some configuration that can run 5 or 15 VMs and wire them together, right? And the configuration of the test driver is also not trivial, so I have the test module system. What's interesting, if you want to learn about that, in the NixOS modules folder under virtualization, you see those profiles. These are worth studying because they are also worth without the test driver. The test driver Python project is under NixOS/lib test driver. And then the packages testers run NixOS testing with the attribute set that automatically wires everything together. That is under NixOS/lib/testing, which is also documented because it uses the normal NixOS module system like the NixOS modules too. And that together wires up the whole powerful test driver framework. There's also new debug hooks. So that is a feature that's really worthwhile mentioning because sometimes people told me like, look, we have tests that run like for 5 hours and then they fail, but they never fail on the laptop. So what to do? You can enable the debug hook and configure your Nix builder accordingly. And then when it fails, like next week or something, then you can log into the builder and the test is being frozen for you and you can actually log into the machines. There are some complicated lines here. The test driver will print them for you. It's just to be mentioned here for you that you can actually freeze failing tests on remote infrastructure if they are hard to grasp why they fail. Then you can log in and debug the hell out of it and finally fix it. So that's relatively new. Container tests. So customer asked me like last year, how would you do GPU testing in the sandbox? And we discussed it a bit more, and then we realized, look, so if we could kind of add containers to the test framework, that would be more than you're actually asking for. But it would make everything also interesting for the public. So the public would gladly accept that into the upstream Nix packages, and then you get what you need, and you don't have to maintain it because the community thankfully accepted the whole thing, kind of, and everyone profits from that. Shall we try that? So they were like, yeah, let's do that, and now it happened. So we are nearly merged. We can now run containers. What that means is that instead of running QEMU VMs, we just run systemd-nspawn containers, which are faster because you don't have the overhead of a new kernel and hardware models and stuff like that. And the cool thing is, instead of writing nodes.machine name equals blah, 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 you say containers.machine name equals blah, 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 and that's it. You can basically switch over many tests if they're not graphical and so on. What's also nice is that you can combine VMs and containers, and these are kind of fast and light, right? So you cannot run 150 VMs on your laptop, but you can always run 150 containers. It's possible. Also, we are kind of relieving people that used the test driver before to use bare metal infrastructure because you need KVM acceleration and typically nested VMs don't work well. So you needed bare metal infrastructure to run NixOS tests quickly. Now you can use cheap VMs and they just run without overhead with containers. So that's a huge liberation from certain hardware requirements that we don't need any longer. And the final goal for our customer was that we can now map GPU devices from /dev/blah, blah, blah into the container, into the VMs, and run CUDA in the container, for example. This is kind of the CUDA example. Sorry, I didn't know that the board would be so small. We have containers.myContainer equals NixOS configuration. And here we installed saxpy. That is a minimal CUDA application to test if CUDA is configured at all. And here's a list of paths that we make available from the host into the sandbox and then into the container. So you just need to list them up. And then in the test, we basically run saxpy. And that program would crash if CUDA wasn't available, but here it doesn't. And that's it. So we can run CUDA stuff inside the NixOS integration test, which is pretty cool because many real-life products are deeply embedded in some NixOS configuration. And this way, you can finally have very production-near scenarios on your laptop, basically, or whatever hardware has NVIDIA cards. To enable this, we need to set up the Nix daemon in the config. So we need to allow for auto-allocate UIDs and cgroup stuff. The thing is that systemd needs to manage a lot of like mappings between user IDs, identities, and stuff like that. It's really complex. You can also not run any SUID stuff inside that, but even Lennart Pöttering, the main systemd maintainer, started hating SUID, so that will most likely vanish anyway. We're a little bit at the edge, kind of, but this will improve anyway, and it works pretty solid and well. Upstream container support will be available in 26.05 in a few months, but I expect the pull request to be merged in a few weeks already. There's a lot of review that happened and improved it very nicely. And I have an example test, as you see later, 2 containers pinging each other and then dying again is 2.4 seconds in total with all boot stuff and so on. A special thanks to the Clan project who wrote the first proof of concept of container tests. And also JFly and KMine, who worked for us to implement this in an upstreamable way, which was a lot of work, but they did that so perfectly. And Mar27, he sits in Stuttgart, works for Secunet. He helped us review that stuff, and he also exposed some more optimization potential which made this amazing. If you want to try this out now, check out the Nix packages fork of applicative systems. It's in the branch NixOS test containers. We'll do that later too, if you want to see it. One word about the NixOS documentation. People typically find out that when you Google stuff about Nix packages or NixOS, you find nothing, just blog articles of people and so on, but not the primary documentation. That is because the Nix packages docs and NixOS docs are one huge HTML document, so large that Google does not index it. So until that is fixed, please bookmark these pages and use Control F inside, and you will immediately find what you need, because everything I just talked about is documented already. It's just that you can't Google it. That's the only thing. Last slide. Thank you for listening. So we do NixOS training and consulting. I love this project because we had a customer sponsor this nice open source stuff, and everyone profits from this now. And our lever was that we, of course, know the right people, so who to nudge to get complex changes upstream and to redesign this in a way that's actually upstreamable. We really much enjoyed that. Yeah, so there's also our newsletter. So you can scan this QR code or look for Nix Academy newsletter. We typically send monthly updates on what happened in the blogosphere with nice summaries for people who are thin on time. Thank you for your attention.